Yeah, very good morning, students. Yes, hope it is audible.
Yes, sir.
Yes, sir.
Okay, because I did not get any response when I said very good morning. Nobody says good morning. Hmm? Okay. Uh, yeah. So to begin, what we have discussed in the last class, is it possible to say Tipana?
Yes, sir. The Gram-Schmidth, sir.
Yeah, what it is?
Orthogonalization.
Yeah, what it is?
So, like to determine the finite sets of n orthogonal functions.
Yeah. So Gram-Schmidth orthogonalization procedure is used to determine the uh, finite set of n orthonormal functions. Why we wanted to find the n orthonormal basis functions? What is the purpose?
So, like to express the linear combination of these
Yeah,
functions.
so that we can express the m finite energy signals, right, as a linear combination of these n orthonormal functions. So that is the purpose, right? So with that understanding, I started explaining about the procedure, that is how to determine the basis functions, right? I told what is the procedure for finding pi1 of t, then pi2 of t, right? So now, with this understanding, now let me generalize how to determine pi I of t, means any value of uh, the basis function, okay? I think, 1 minute. Sorry. Yes, are you able to see whiteboard? No, no? It disappeared, right? Hello?
Yes, sir.
Yeah, just 1 minute, something happened. Okay, in the meantime, do you have any questions to ask? You can ask. I think it is taking time, 1 or 2 minutes. And I found again some 20 people have not yet submitted their assignment in the Google Classroom. Though they are active in regular class, but they are not submitting. I don't know why. Some are active, but not all. But those who are active, they are not. They are neglected, I think. Hope you understand my this one. Hmm? Though they are active in class, but they are not submitting the assignment. Any problem? You have to work hard. It is little bit hard compared to any other subject. You may be understanding by this time. No, you cannot write any story, right? You have to begin with mathematical formula, right? Yes. Theory writing story is very little in this. See, Hilbert transform, you cannot write any story, right? All the topics, whatever the topics we have discussed so far, it begins with the mathematical equation. What happened? Stop. No, no. That is why I periodically gave some assignments so that you will be in a regular study. Hmm? Uh, so just it is a reminder, those who have not made their mind to submit first assignment and second assignment, they should submit. Okay, you all know how we finalize the marks. So marks is one thing, but as part of your learning, okay, you have to learn with interest, not just marks and is there, then you have to submit. Huh? It is not like that. If you learn, understand, then you should think how to apply all these concepts with your digital communication, means any communication system with respect to that. Okay, how these concepts are going to help us in designing a communication system. Okay, fine. I think you are able to see now.
Yes, sir.
Even for this also, people don't respond. Are you able to see? Means, hmm? Yeah. Here, see, pi 1 of t. I said it is s1 of t by s11, right? And finally, I wrote what is s11? That is root e1. I can say pi 1 of t is equal to s1 of t divided by square root of energy of the signal s1 of t. That is root e1. And this is how I express the m, and that is energy signal in terms of basis function. Okay. Yeah. I think. So, are you able to see any story here? Nothing, na? So it is all with mathematical, this one only, right? Yeah. So I wrote this is pi 2 of t is equal to g2 of t divided by the energy of that signal, g2 of t, right? This is how I write 0 to t g2 square of t into dt. Square root of that means square root of energy of the signal, right? So energy of a signal g2 of t is what? 0 to t g2 square of t into dt. So I can generalize now the intermediate signal also. What is that intermediate signal I have taken? Any one of you can say G2 of t. I wrote an expression. What I wrote for G2 of t? Yes,
S2
quickly.
of minus S2151 of t.
Yeah, G2 of t is equal to S2 of t minus S21 phi 1 of t, right? So now let me generalize that intermediate signal so that I can write for any value of I, right? And then I can generalize even this orthonormal basis function also. Yeah. So let me, I said I can generalize in general, I can write gi of t, gi of t, okay, gi of t is equal to, I can write si of t, si of t, okay, minus summation j is equal to 1 to I minus 1, okay, into Sij, fine, pi j of t, Sij pi j of t. So this is the generalized expression for the intermediate signal gi of t. Okay, so I hope we'll be able to understand this, right? You can substitute. If I say I is equal to 2, what I get? G2 of t is equal to S2 of t. Since I is 2, so it will be 2 minus 1 is 1, right? Means the value of j is 1 to 1, it varies. That is S21 by 1 of t I can write, right? Okay, so how do we determine the value of Sij? Yes, Sij, that is the coefficient, no? So what is the expression for finding the coefficient? Yes, quickly, any one of you can say what is the expression I told for finding the coefficient? Sij. Yes, I'm expecting answer from you people.
So
Sij.
integral 0
Yeah,
to t I of t phi j of t
yeah,
dt.
yeah. Sij. There is a coefficient, right? So which is equal to integral, right? 0 to t Si of t, Si of t, pi j of t, pi j of t into dt, I can say, right? So where the value of uh, j can vary from 1 to n. That is here it is I minus 1, I can say, right? The value of j can vary from 1 to 1 so on up to I minus 1. Okay. Yeah. In the same way, I can write what is pi I of t also. I can generalize pi I of t. So, yes, any one of you can guess what can I write for pi I of t in terms of gi of t? Yes, pi I of t. I wrote what is pi 2 of t, no? That is g2 of t divided by square root of the energy of that signal g2 of t, right? Can I write pi I of t? Okay, pi, sorry, that is sorry, 1 minute. If I scroll up, is it fine?
Yes, sir.
Yeah, I think. Yeah, I can write pi I of t as pi I of t will be equal to, can I write here gi of t, right? And then integral 0 to t, so that is energy of the signal, right? G squared I of t into dt, then you can take square root of that, right? Sorry. Yeah, let me write here. Let me say it is equal to t. Is that fine? So can I write like this? Pi I of t. So the value of I can be anything. It may be 1, 2, 3 up to m. It can vary, right? So we'll keep this generalized expression for finding any value of basis function. Hope is it possible to say what is the equation number I can say for this? Have I given what is the previous equation number? Give some number for this. Okay. So this is what the procedure is. Now let me take some example. Okay, how to find or how to determine the orthonormal functions, and as well as how I can express the m finite energy signals in terms of these n orthonormal basis functions.
So can you scroll up 1 minute, sir?
Okay, I will scroll up. Is that fine?
Yes, sir. Done, sir. Thank you.
Fine. Okay. Okay, now let us take the example. Okay, consider the signals. Consider the signals consider the signals S1 of t, okay, S2 of t, S3 of t, and S4 of t, and S4 of t. So I have 4 signals, okay, as given below. So let me write the first signal. Okay. So this is time, and okay, so this is my S1 of t. Okay, this S1 of t, I think I will write all 4, then I will write with the so this is my S2 of t, and another signal is S3 of t, and one more I said it is S4 of t. Okay, now let me write its existence. That is, so S1 of t exists over 0 to t by 3. Okay, oh sorry. Yeah, this is 0 to t by 3, the magnitude of 1. Okay, and S2 of t, okay, S2 of t exists till 0 to 2t by 3, 2t by 3, the magnitude of 1. And S3 of t exists from t by 3 to t. Okay, t by 3 to t. and its magnitude is 1 there. And S4 of t is from 0 to t, the magnitude of 1. Okay. So these are the four signals given. Okay. Find, I will not write the sentence, you please note down this. Find an orthonormal basis, find an orthonormal basis for the set of signals, find orthonormal basis find orthonormal basis for the set of signals using Gram-Schmidth orthogonalization procedure. Using Gram-Schmidth orthogonalization procedure. So I am writing in short, GSOP. Yeah. So looking at the signals, what you all understand? All these four signals are linearly independent, or is there any dependency among some signals? I hope you are understanding what I am asking. So looking at these four signals, do you feel that all these four signals are linearly independent, or is there any dependency of one signal on the another signal? Hope understood my question. Yes, you should say yes or no. Have you understood my question?
Yes, sir.
Oh, so can I expect any answer from you people?
Independent. Teacher.
All are independent. All four signals are independent. You just see the duration of the signal. See, first signal exists from 0 to t by 3 with a magnitude of 1. Right? The second signal S2 of t exists over interval 0 to 2t by 3 with a magnitude of 1. Then the third signal exists from t by 3 to t with a magnitude of 1. Then the fourth signal, that is S4 of t, exists from 0 to t with a magnitude of 1. So looking at these four signals, can I say, am I able to get some signal by adding some signals?
Yes, sir.
Yeah. What is that signal I can get by adding what and what signals?
You can get S4 by adding S1 and S2.
S1 and S2.
S2 and
And
S,
S3 will give S4, sir.
S3 and S1.
S3 and S1, right? Very good. So I can get S4 of t, right, by adding S1 of t and S3 of t, right? Because S1 of t exists from 0 to t by 3 and S3 of t exists from t by 3 to t, right? So by adding these two, S1 of t and S3 of t, I can get the S4 of t. So all these four signals are not linearly independent. I miss S4 of t. It depends on these two signals, S1 of t and S3 of t, right? So looking at this, I can say the number of basis functions will be less than the number of these finite energy signals, right? So here there are four energy signals. No, obviously it will be less than or equal to 4. Okay, so I can write as a beginning step only. I can say S4 of t. S4 of t will be equal to, as a solution part, what I can write. So first you need to observe. Okay, so I can write S4 of t will be equal to S1 of t plus S3 of t. So I understand that the number of basis functions will be anyhow less than or equal to the number of energy signals. Since S4 of t depends on these two signals, so I will get less than 4. Okay, that is fine. Next, yeah, what is the first step? How do we go about this? Yes, what is the first step? What I found in step 1? Yes, see, just now I told about the procedure, no? GSO, that is Gram-Schmidth orthogonalization procedure, right? So how do I go about this? See here, this is an example, right? 4 signals are given. Now, to begin with this, I need to find out the pi 1 of t, no? In the first step, right? So to find pi 1 of t, I know what is the expression for pi 1 of t. That is S1 of t by root of E1, right? So what is that? E1 is the energy of the signal S1 of t. So I need to determine what is the energy of the signal S1 of t as a first step, right? After finding energy of the signal S1 of t, then I can substitute in the expression for pi 1 of t and I can say what is pi 1 of t. Is that fine? Yes, I am asking, is that fine? Yeah. So to begin with, so now let us first determine what is the energy of the signal S1 of t. Okay. So energy of the signal S1 of t, what I denote, that is E1, which is equal to integral, I write 0 to t S1 square of t into dt, right? So just I wrote the expression, right? So now let me write this S1 of t exists over what interval? Yes, S1 of t exists over what interval?
0 to t by
Yeah. So now the limit have to be changed by 0 to t by 3, right? So 0 to t by 3. So what is the value of S1 of t over interval 0 to t by 3?
1.
1, right? So you can write 1 square into dt. So which is equal to what I can write? 1 square is 1 only, right? So upper limit minus lower limit. So can I write it is t by 3? E1 is equal to t by 3?
Yes, sir.
Yeah.
Yes, sir.
Yeah. So E1 will be equal to energy of the signal S1 of t, which is E1. I get it is t by 3, right? Okay. So now let me write the pi 1 of t, right? Hope written, na? If I scroll up is fine.
Yes, sir.
Yeah. So now let me write the expression. I said WKT means we know that, right? What we know, pi 1 of t will be equal to S1 of t, right? Divided by root of E1, right? So which is equal to what I can write? What is the value of S1 of t? It is 1, right? Over into 0 to t by 3. Then it is root of, sorry, yeah, it is root of t by 3, right? So which is nothing but what can I write? Can I write it is root of 3 by t? Yes, is it fine?
Yes, sir.
Yeah. So I can say pi 1 of t, right? So pi 1 of t will be, sorry, pi 1 of t, yeah, pi 1 of t. So pi 1 of t will be equal to what I can write? It is root of 3 by t Over what interval I can write? I should specify this time over an interval of sorry, 0 to t by 3, and it will be 0 elsewhere, right? Otherwise it will be 0. Okay, so this is the value of pi 1 of t, and even if you want to write, you can write what is S11. S11 is nothing but root of E1, right? Root of E1. So you can say, you can substitute S11 as what? E1 is t by 3, right? You can write root of t by 3 also. Okay, so I can represent this pi 1 of t graphically like this. So this is time, right? And this one is what? I can write pi 1 of t. Okay, so 0 to t by 3 with what magnitude you have to write? Yeah, so its magnitude will be what? Root of 3 by t. Is that fine? So this is how I represent the pi 1 of t signal. That is the orthonormal function. Yes, is it clear? The first step?
Yes, sir.
Yes, sir.
Yeah. Yeah, what is the second step? What we found in second step?
P of t, sir.
Pardon? Yeah, we need to find
P
pi
of
2
t,
of
sir.
t. Yeah, to find pi 2 of t, either you can write the generalized expression, right? That is what I said, g2 of t, na? Yeah, let me write step 2.
So can you scroll up a little, sir?
Yeah, I will scroll up. Uh, yeah, is it fine? Or still you want me to scroll down? Yeah, I began with this. Step 1, I started finding the energy of the signal S1 of t. I wrote it is S1 of E1 is equal to 0 to t S1 square of t into dt. I said S1 of t exists over an interval 0 to t by 3. I substituted the value of S1 of t and I found that it is t by 3. Right? Then I know what is the expression for pi 1 of t. I substituted the value of S1 of t and the energy of the signal S1 of t, and I could write it is root 3 by t. Right? That is 1 by root of t by 3. It can be written as root of 3 by t. Fine. Yes, shall I go up? That means, shall I scroll up? Yes, I'm asking, shall I scroll up? Is it written?
Yes, sir.
ಅವನಲ್ಲಿ ಪ್ರಜ್ವಲ್ ಏನು ಮಾತಾಡ್ತಾ ಇಲ್ವಲ್ಲ?
Yeah, sir, I'm telling, I think you couldn't hear me. Done, sir.
Okay, man, fine. Yeah. So the next step is what we need to find out pi 2 of t, right? So for finding that, I said the intermediate signal we write, right? What is that intermediate signal I used to write? That is G2 of t. First, let me write that G2 of t. Uh, yeah, G2 of t is equal to S2 of t, right? S2 of t minus S21 pi 1 of t, right? S21 pi 1 of t. So first, let me determine, and even let me write even expression for pi 2 of t also. See, pi 2 of t is equal to what I can write, G2 of t divided by square root of integral 0 to t G2 square of t into dt, right? Okay, so in this expression, first that is I need to find first G2 of t, right? Then only I can find out what is pi 2 of t. So for finding, I said that it is an intermediate signal, right? So G2 of t is S2 of t minus S21 pi 1 of t. So first I need to find out what is S21. Okay, so what is the expression for S21? I can write that is Sij expression I said na, S21. Yeah, quickly any one of you can say what can I write for S21? Yes, S21.
Integral 0 to t s2 of t phi 1 of t dt.
Yeah, integral 0 to t, right? S2 of t, then pi 1 of t, right? Into dt. Is that fine? Yeah. So now, see, S2 of t exists for what interval? S2 of t. Yes, what is the duration of the signal S2 of t? Yeah, that is 0 to 2t by 3. But pi 1 of t exists for what interval?
0 to t by 3.
Yeah, yeah. So for just I will write here S2 of t, right? I know S2 of t exists for a period of 0 to 2t by 3, but pi 1 of t exists only over what interval? 0 to t by 3, right? After t by 3, its value is 0. So can I write S21 is equal to integral 0 to t by 3. During that time, the value of S1 of t is 1, right? And the value of pi 1 of t is what? Yes, what is the value of pi 1 of t?
2 3 by t.
Yeah, root of 3 by t, right? Into dt I can write, right? So which is equal to what I can write? Yes, what can I write? So root of 3 by t, right? Into what? T by 3 can I write?
Yes, sir.
Uh, so which is equal to what? Can I write it is equal to root of t by 3? Yes, can I write is equal to root of t by 3?
Yes, sir.
Yeah. So S21 will be equal to what I said, it is root of sorry, yeah, root of t by 3, right? Over what interval of time? Over 0 to t by 3, right? When t is less than or equal to t by 3 and greater than or equal to 0, and it will be 0 elsewhere. Okay. So I found S21. Okay. So can I then what is there? S21 into pi 1 of t I need to do, no? So S21 is root of t by 3 over 0 to t by 3. Then pi 1 of t is also, what is the value of pi 1 of t? It is root of 3 by t over the interval 0 to t by 3, right? So what is the product of that I get? Yes, if I scroll up, is it fine? Yeah, what I am asking is, I found what is S21, right? After finding S21, so let me write what is S21 into pi 1 of t. So I know the value of S21 is root of t by 3, right? Or interval 0 to t by 3. And even the value of pi 1 of t is what? It is root of 3 by t, right? Over the interval 0 to t by 3. So which is equal to what can I write?
1.
Which is equal to 1, right? Yeah. So I can say which is equal to 1. I will write here only. Over what interval? Over, sorry, 0 to t by 3. Okay, and it will be 0 elsewhere. So I found what is S21 pi 1 of t, and I know what is S2 of t. So now can I find G2 of t? Is it possible to find G2 of t? Right. So G2 of t, I said G2 of t is equal to what? S2 of t minus S21 pi 1 of t, right? So hope you people have noted. So I'm scrolling up. Just first let me draw it graphically, whatever the things I have got it. Yeah. So I will write with graph. Okay. So first let me write what is S2 of t.
Huh?
Now? Hello.
It's very audible.
Thank you. Yeah, I said the S2 of t, right? S2 of t is what it is 0 to 2t by 3. Its value is 1. Okay.
Huh?
Value is 1.
The G2 of t will be 0, is it, sir?
Man?
So G2 of t will be 0 now, sir.
No, no, it will not be 0. That is why I said no. The expression for G2 of t is what I wrote. it is a S2 of t minus S21 pi 1 of t, right? So I found what is S21 pi 1 of t, and I know what is S2 of t, right? So that one only I am finding it now, G2 of t. Okay. So now let me draw S21 pi 1 of t. Here only. Okay. So this is what S21 pi 1 of t. Okay. So S21 pi 1 of t, what is its value? Yes, what is its value? It is 1 over what interval? 0 to t by 3. Hope you're understanding what I am writing. So 0 to yeah. So let me take small interval, so that is 0 to t by 3, right? It is 0 to t by 3, and its value is 1. Yeah. So my G2 of t, right? So G2 of t will be equal to what I said. It is S2 of t minus minus S21 pi 1 of t, right? So now I return what is S2 of t and what is S21 pi 1 of t, right? Yes, hope you're understanding what I'm doing. See, if you subtract these two, what I get? See, this much portion, no? That is, if I take this as t by 3 till this portion, right? Till this portion, it is common. Okay, right? So 0 to t by 3, S2 of t is also 1 and S21 pi 1 of t is also 1. But from t by 3 to 2t by 3, the value of S2 of t is 1, but the value of S21 pi 1 of t is 0. So what can I write?
It'll be 1 from the interval t by 3 to 3 by 3.
Yeah, so it will be 1 from t by 3 to 2t by 3. That is why I have drawn this graph. So without graph, what Kuber was telling, no, it is 1. There is something he was telling, it is 0. So we will get that interpretation. We need to do this by graph only. Okay, then only the calculation will be proper and clarity will be there. Hope this is clear what I am saying. Hello.
Yeah, sir.
Sir, there's no
So
formula to find S2 of t. Sir, like how we found S1 of t.
that one only I am doing it now. For S2 of t.
Yes, sir.
No, S2 of t is given, no man. What you wanted to find again? S2 of t is there, right? For finding G2 of t, means for finding pi 2 of t, I am doing this circus.
Yeah, got it.
S2 of t is given already, right? Yeah. Sorry.
Yeah.
So initially we assumed E1 equals to S1 of t, right? So in that
No,
way,
it is
can't
not
we
assumed.
find?
It is not assumed.
Okay.
It is not assumed. No, where I am not assumed. E1 is equal to what? That is the energy of the signal S1 of t, na?
Yeah, sir.
Yeah. So if I go with this, then I can say what is okay. Of course, I am drawing slightly. There is an orientation. I am unable to write with proper vertical. Please do it properly in your notebook. Okay. So this is my G2 of t. So I can say G2 of t will be equal to what I can say. It exists. Okay, from t by 3 to what value? 2t by 3. Okay, I can write this pulse. Okay, and its value is 1 there. So I can write it. Hope clear, na? I would have written one below the other vertically, then that picture would have been very clear. Okay, there is slight orientation in my write-up. So please try to understand that. So what I can say, G2 of t will be equal to, I can say it is 1 over what interval? Over 2t by 3 to t by 3. Okay, and it will be 0 elsewhere. So now I found what is G2 of t. Then I can find out what is energy of the signal, right? If I find what is the energy of the signal, then I can substitute in the expression for pi 2 of t to find what is pi 2 of t. Okay. So any one of you can say what is the energy of the signal. I denote energy of the signal as Eg2 of t. Yeah. Yes. Any one of you? Yes. I think people are asking now, unable to turn on their mic. Now they can. They should. Yes. Manoj. Manoj is there.
Yes, sir.
No, Manoj. Can you tell, man, how do I find the energy of the signal G2 of t? I said it is Eg2 of t. Can you say the formula? See, G2 of t is there here. Okay, it exists for what interval? I wanted to find energy of the signal. What is the expression for that? I'm asking.
Sir, integral, sir. Integral G2 of
Integral. You tell the expression, no? Integral 0 to
uh,
t.
G2 of
Yeah, G2 square of t
T
into dt, man. So this is the expression for finding the energy of the signal. Okay, so now do you think that G2 of t exists for the interval 0 to t, or what is the integration limits I have to change?
T by 3 to
Yes, I'm
2t by 3.
yeah. So here the integration limits are from what? T by 3 to 2t by 3. So energy of the signal Eg2 of t will be equal to what? I can say it is integral is from, sorry, yeah, t by 3 to 2t by 3. The value of G2 of t is 1, right? So I can say 1 square into dt. Yeah, any one of you can simplify and say what is the value? That is upper limit
T
minus
by
lower
3,
limit,
sir.
right? So 2t minus 3,
T by 3.
yeah, it is how much? Yeah, t
P
by
by
3.
3.
So upper limit minus lower limit. If you do that, you will be getting t by 3. Okay. So this is my energy of the signal Eg2. That is G2 of t. Okay, that is the energy of the signal G2 of t. So let me write here G2 of t. Okay. Yeah. So after finding the energy, then I can say what is pi 2 of t. Yeah, what is pi 2 of t expression? Yes, Rushank, can you tell what is the expression for pi 2 of t, man? Rushank. Siddharth. Yes, Aditi. See, nobody responds. It means they are not here. So G2 of t will
Yes,
be
sir.
1, okay, over the interval t by 3 to 2t by 3, and the energy of the signal will be what? It is t by 3. I can write root of t by 3. So which is equal to, can I write root of 3 by t? Yes, can I write root of 3 by t?
Yes, sir.
So it will be root of 3 by t over what interval? over an interval of t by 3 to 2t by 3, right? So 2t by 3 from t by 3 to 2t by 3, its value is root of 3 by t, and it will be 0 elsewhere. It will be 0 elsewhere. So I found what is pi 2 of t. Okay. So this is the second step. So next step is we need to find out what? Yeah. So is it fine? I hope everybody is following. Yes, I'm asking people, do you have any doubts with respect to solving this? I wrote all these things. Have you understood all these things?
Sir, in the first line,
Ah,
we have done
ah,
S4 of t is equal to S1 of t plus S3 of t, sir.
yeah,
What,
I will come
what,
back to that. Sorry. Yeah,
that's what, sir,
yeah,
like,
what that?
why did we like write that, sir? We have not used that anywhere.
No, it will come. It will come. No, why means what I sorry. Uh, what I wanted to say is, so looking at the signals, I said actually we use this Gram-Schmidth orthogonal procedure for determining orthonormal functions, and we wanted to express the linearly independent energy signals in terms of these orthonormal functions, right? I wanted to say here all these four signals are not linearly independent. Okay, some signal is dependent on another signals. So what is the dependent signal? S4 of t. I can obtain S4 of t by adding S1 of t and S3 of t, I said, because S1 of t exists from 0 to t by 3 and S3 of t exists from t by 3 to t. So by adding those two signals, I will be able to get S4 of t. So I can say S4 of t is not an linearly independent signal because it depends on S1 of t and S3 of t. Oh, understood.
Yeah, okay,
So
sir.
with that, what I can say is uh, I need not find pi 4 of t. Okay, till pi 3 of t is enough. We will understand that as we go further. Okay. Yes, sir. Hope I cleared your doubt.
Yes, sir. Yes, sir.
Yeah. So then I began with the finding energy of the signal S1 of t. Then I found what is pi 1 of t. So I expressed pi 1 of t. Right. In the second step, I took the intermediate signal G2 of t. Right. From this G2 of t, I understood it is S2 of t minus S21 pi 1 of t. So first I found what is S21. Then I found the product S21 pi 1 of t. Then I could subtract that from S2 of t. Then I got G2 of t. Then after finding G2 of t, I have to find energy of the signal to find the pi 2 of t, right? So that is what I have done here. And I said by drawing graph only, you will be able to get the clear picture about the duration of the signal. Okay, don't just with mathematical equations, don't go. Then I could find out what is pi 2 of t. Now let me express or draw graphically this pi 2 of t also. So pi 2 of t, I will draw this. So this is time, right? And I can say, yeah, this is pi 2 of t, right? So it exists from t by 3 to 2t by 3, right? You can write that limits t by 3 to 2t by 3. So over this interval, the magnitude of the signal is how much? It is root of 3 by t, right? Yeah, and its value is what? Root of 3 by t. Okay, this is how I represent pi 2 of t graphically. So as a next step, I need to find out G3 of t. I write the expression for G3 of t. Already I wrote na G, what is G2 of t in the same way. Or I generalize the expression Gi of t. Okay, then find out the coefficients. then find pi 3 of t. Okay, I think you will be able to do that. I think I will give that as homework, or let me solve tomorrow. Okay, you try from your end. So if you are not getting, then I will solve. Okay,
Sir,
is that
actually,
fine?
in step 2 for S2 for G2 of T, we used to assume that Sij equals to 0 except S21 and S22, no, sir?
That is what, man. See, I took. See, yeah, tell me.
In for phi 3, what should we like? Except what we should take, sir?
Yeah, that is what I wrote the generalized expression. Gi of t. See, Gi of t is equal to what I said. Si of t minus summation j is equal to 1 to I minus 1. Sij pi j of t.
Yeah.
Right.
Yes, sir. Yeah.
Yeah. Here you have to write I as 3. Then G3 of t is equal to what you will get? S3 of t minus summation j is 1 to. So 3 minus 1, it is 2, right? So j is 1 to 2, it will vary. Then what you can write? S2 1 pi 1 of t. Then next term is what? When j is 2, that is S2 to pi 2 of t. Hope I
Yeah.
answered your
Got it,
question.
sir. Yes, sir.
Uh, yeah, like that you have to write that one. Okay, so when I is equal to 3, I get G3 of t, no? So which is equal to S3 of t minus summation j is equal to 1 to 2 S3j pi j of t will get. So just write the S3 of t minus, so substitute the value of j as 1 first, means you will get S31 pi 1 of t, right? Then minus S32 pi 2 of t. So you need to find out S31, then you find out the product of S31 pi 1 of t, then you find out S32, then you have to find out S32 pi 2 of t, then you have to subtract those two terms from S3 of t, then you will get G3 of t. After finding G3 of t, you have to find the energy of the signal G3 of t. After finding energy of the signal G3 of t, then you can find out what is pi 3 of t. Okay, so that is a procedure. So try from your end. Okay, so I will continue in the next class further. Is that fine?
Yes, sir.
Any difficulties people should ask, because it is an important topic. Definitely, whatever the problem I have taken it today, it will come. It will be asked for 12 marks. Okay, so I took more than 1 hour.